Okay, ladies and gentlemen, let's talk about an easier way to do some of our vectors. Now, the last way involved taking our vectors, physically lining them up, using parallel lines, using the law of cosines, using the law of sines to find the angle and the direction. There's a significantly easier way to do this. Now, it involves a few more steps, but those steps are a little easier. Let's take our vector A right here, and let's deal with just him a minute. So let's make it a little bigger. 4 at 45. Now here's the thing. Every vector, every component, or every vector in any direction has what are called components. Think about it like this. If you want to go from here to here, that's fine to walk in a straight line unless, of course, there's a building or something in the way. So the other way to do it is to go around the block. You would go over to here, and then you'd turn and go up. And so you would move this way, and then you would move this way. So I could take one big vector and break it into its two components. In this case, since we're moving left and right, this would be the x component, and not shockingly enough, this would be the y component. So to get the x component, the y component is really not that big a deal, because in essence what I do is split this up into a right triangle. If I know 45, and I know 4, how do I find x? Well, that's going to be the adjacent side and the hypotenuse. So I could say cosine of 45 degrees equals adjacent side x over 4. So adjacent side x over 4. Now, if I want to do the y value, I would say sine of 45 equals y over 4. But to get x or y by itself is super easy. Multiply by 4, multiply by 4. So I get 4 sine 45 degrees. Here I multiply by 4, 4 cosine 45 degrees. And so we end up with y equals r sine theta, and x equals r cosine theta. And those are two very easy formulas to use to take one resultant r, or radius, and break it up into its x part and its y part. So from that, we can actually find these. Now, of course, we know that the cosine of 45 is 1 over root 2, so 4 times 1 over root 2. I have the x part of the vector is 4 over root 2, comma. The y part of the vector is, well, sine of 45, 4 times 1 over root 2 is 4 over root 2 over here as well. If I wanted to put those into a decimal, I could simply do a straight up division and make sure that it turns out to be a decimal. So let's see here. We could say 4 divided by second square root 2. And that's about 2.8, which obviously means this is going to be about 2.8. You'll notice we've talked about this when we talked about translations, and that is the arrows on the end mean this is a vector. It's going to move this way and this way, this way and this way, not a parentheses, which makes a point. So that's our vector for this. So you could list this vector as 4 comma 45 degrees, or 2.8 comma 2.8, which means from the center you would go over 1, 2, almost 3, up 1, 2, almost 3, and that would give you the vector. Now, let's do the same thing over here. X equals r cosine theta, y equals r sine theta. Let's plug them in. So let's drop an altitude, and we say x and we say y, and so we say the radius is 6, and it's cosine of 285. Now it's important that we use the 285 because that's going to determine whether this turns out to be positive or negative. Here we're going to say y equals 6 sine 285, and we will work both of those out. Now we can't use a special deal on this one because it is not one of our special triangles. So cosine 285 times 6, the answer is 1.55. So x equals 1.55. Y is 6 times sine 285, and that is negative 5.8. Negative 5.8. Now, of course, why is it negative? It's going down. So by going down, the negative indicates I'm going to go down. To put this in component form is super easy. 1.55 comma negative 5.8. Now you say, okay, well, that's a lot of work to split one number into two numbers. But here's where it pays off. If I wanted to do the exact same problem that we did last time, which was a plus b, we had to do the big fancy triangle. We had to do law of cosines, law of sines. Here we don't have to do that. All I have to do is take this, a, 2.8, comma 2.8, plus b, 1.55, comma negative 5.8, and my answer is going to be 2.8 plus, take the x part here and the x part here and add them up. Take the y part here and the y part here plus negative 5.8, very important, and add them up. So my answer here turns out to be 2.8 plus 1.55, 4.35, 2.8 plus negative 5.8. Answer is negative 3, and there you go. So my vector is over 4.3 down, or 4.35 and down negative 3. By the way, let's see if that would make sense. Do we go over 4 and something and down 3 to make this blue line? The answer is yes. So very quickly, if I have this component form, I could do all sorts of crazy things with them. If I have a equals 2.8 comma 2.8, b equals 1.5 comma negative 5.8, and c equals some other vector, negative 2 comma negative 5, and d, the vector, equals 1 comma 4, I could do all sorts of things. Problem number 1, a plus b plus c minus d. Okay, now if I were to draw this, this would have been up, down, then it would be negative 2, negative 5. So back 2, 1, 2, down 5 here, and then up 1 over 4. So it looked like this. So this would be like taking a zigzag pattern. Guy walks this way, this way, this way, and this way. Well, where did he really walk? The answer is from tail of the first to head of the last, and went straight there. You would not want to do that using this method because it would take at least 3 laws of cosines and 3 laws of sines. But in our case, it's super easy. Let's take A. And let's go 2.8 comma 2.8 plus b, which is 1.5 comma negative 5.8, plus c, negative 2 comma negative 5. Now, let's stop there and just add those up real quick. Add all the x pieces. 2.8 plus 1.5 plus negative 2. The answer is 2.3. And then I take 2.8 minus 5.8 minus 5. Answer is negative 8. There you go. And so that would be A plus B plus C. But to do minus D, here's what I'm going to do. Instead of taking 1 and 4, what would minus this be? Negative 1, negative 4. So we put the negatives in, and there we go. Let's put them together. I get 1.3 comma negative 12. And with that, I have the correct vector. And how long did it take me to add all 4 of those compared to how long did it take me just to add 2 of the others? So component form is super useful. If I have 6, for number 2, if I have 6, A, all I have to do is take the A, which is 2.8, and 2.8, and multiply it by 6. So I say 6 times 2.8. Answer is 16.8, comma 16.8. And there's my answer. The component forms may take a little longer to get, but they're actually very easy to do. So here's what I want you to do. I want you to do number 3. I want you to do 2b plus 3c. Number 4, d minus b. Number 5, a plus d minus c. And then for number 6, I want you to do the following. I want you to find the component form of this vector. 7 units at 15 degrees. So you need to find x and y. Okay, good. Do that.